Alright, orbits. So these I advise you to memorize, because, like I said earlier, like the multiple choice questions that they give you, they tend to be like, recall the second law, or which laws support this, or that, or etc. Or this is happening to this planet. According to Kepler's third law, describe what is happening to the radius. Like, they kind of tend to vary, but the Kepler's laws always seem to somehow get involved in exams, and you probably have seen this when looking at them. If not yet, then you will. So make sure you remember these. Kepler's first law, it's all orbiting planets orbit in an elliptical fashion. So in this shape here, okay? So it's not an oval, it's like more an elliptical shape. Kepler's second law, it's a line joining an orbit body to the center of its orbit, and it will sweep out an equal area in equal time. Okay? You don't really do much with the second law in terms of calculations, it's more so a third law here. So the third law, it's a ratio of the cube of the orbital radius to the square of the orbital period as a constant for a given body being orbited. I'm pretty sure that's given to us here. So the empirical relationship between the period and the radius of an orbiting satellite and the mass of a central body being orbited, that's all to do with the third law. So we can see that here. So we've got the radius cubed divided by time squared, the period of the orbit squared, is equal to the gravitational constant multiplied by the mass of the central body being orbited divided by 4 pi squared. This formula does tend to come up quite a bit, so and it is quite confusing to most. So practice this one religiously, because you'll have to compare like the radiuses and the times between planets and stuff. You'll have to prove that third law. So let's get crack-a-lacking on this question. So it says, the Earth takes 1 year to orbit the Sun at a distance of 1 astronomical unit. And if they talk about astronomical units in the exams, they should provide it. That's how it should be. You shouldn't have to memorize it. From the surface, calculate the mass of the Sun. The radius of the Earth is 6,380 kilometers, and the radius of the Sun is 6.95 by 10 to the 5 kilometers. And do we have space on the next page? We do. Okay, so we're going to use a formula that we just looked at. So radius cubed is equal to time squared, or the period squared, which is equal to the gravitational constant multiplied by the mass divided by 4 pi squared. Alright, and we're going to remember that the radius is going to be in meters. So, we need to make sure we add all 3 of these. So this bit, that bit, and this bit. Alright, so just thinking, yeah. So it's very similar to what we did in the previous question. And we're just going to make sure we multiply it by 10 to the power of 3 to get it from kilometers into meters, because there are 1,000 kilometers in there are 1,000 meters, sorry, in a kilometer. So we'll write that in. So I'll just start with the first one. 1.5 by 10 to the 8. And remembering that we are trying to find the mass. Plus 6380 plus 6.95 by 10 to the 5. Multiply by 10 to the 3. More brackets. Squared. Over period, which is 1 year. Wait, but isn't that in... It's in seconds. Oh, would you look at that? So now we're going to do some magic math here. So if you think about it, 1 year, we've got 1 day, which is 24 hours. So we've got 24 hours, but then it's got 60 minutes in each of those hours, which has got 60 seconds in each of those minutes. And then you've got 365 days a year. So it's going to be a long number. It's going to be 36,000 squared. Oh, I just realized that one's actually cubed. We've got the gravitational constant, which is G. Multiply that mass. Divided by 4 pi squared. What I might do, just because we're running on a little low on time, I might just quickly zip through this question and just put into the calculator and tell you what the answer is. So we got 1.5 10 to the 8 plus 6380 plus 6.95 by 10 to the 5 by 10 to the 3. 315 6. Oh wait. 36000 squared. Divided by 4 pi squared. Oh, it's not divided by, it's multiplied by. Sorry. And then we're dividing by the gravitational constant, which is going to be 6.67 by 10 to the 11, negative 11, I should say, sorry. And that's going to be, our mass is going to be very big. It's going to be 2.04 by 10 to the 30 kilograms. Okay. We're going to go on to the next question. Okay. But yeah, that formula can be rearranged. This is something worth remembering, that it can be derived by the relationship between Newton's law of universal gravitation and uniform circular motion. So yeah, just keep that one in mind.